Hello viewers, welcome back to our YouTube channel, KC Accountants Education Center. Today we want to look at a simulation that will help us to enhance our understanding on the cost of preference share, especially when it's redeemable. So we are going to look at a simulation, and this one is focusing on redeemable debt. So we can write that a 5% bond is currently quoted at shillings 95.84 x int full stop. It is redeemable. It's redeemable at the end of 3 years at shillings 100 full stop. They are continuing that taking corporation tax at 50% and ignoring the timing lag for tax savings. We shall understand what a timing lag is for tax savings. Calculate the cost of debt. So they want us to calculate the cost of debt when we are ignoring the time things to do with tax savings. So solution, let's first see what we have. We have the par value. The par value as 100. We have the coupon interest rate of 5%. So we need to first get what is the interest. So the interest is going to be, of course, we know the interest, we get the coupon rate times the par value for us to be able to compute that. So it will be 5% times the par value is 100, and this is giving us 5 shillings. So the other aspect is the fact that you can adjust this. Remember, we said it is redeemable, which means IRR, but this is supposed to be 1 minus tax. You're supposed to adjust it for tax. That is the cost of this instrument that we are looking at. But now we need to understand, when we are starting, we always invest at the market price. So that means, since we are investing at the market price, we need to first get the MPS. But this MPS should be X int. They gave us the value as 95.84 shillings. It is X int, so we have no problem with it. Now, they have also given us the redemption value, because we know we are redeeming. But now you need to understand there are issues when you are redeeming at redemption. At redemption, we have issues, because you can redeem at par, you can redeem at a discount, and finally you can redeem at a premium. The examiner will tell you how is going to redeem, or how you are going to redeem this debenture. or bond. The other thing is that if the examiner doesn't tell you, if the examiner remains silent, then it is a standard. The standard way is we redeem at par. That is the standard. If the examiner wants you to redeem at discount or at premium, he must give you the redemption value, or he must give you the discount rate that you are going to use. I hope we are at par here. Now let's first have the formula for IRR. When you are computing IRR, it is always small a plus capital A over capital A minus capital B into B minus A. That is always the formula. So that's the formula that we are going to be using. It is small a plus the whole of that, where small a is actually the discount rate, that gives a positive NPV. And small b is that discount rate. It is a discount rate that gives a negative. It's that discount rate that gives a negative NPV. Of course, now you'll be able to know what capital A and capital B. Of course, if you go to capital A, that is the positive NPV. Capital B, that's the negative NPV. So we shall be going through some of these. But now, at the same time, allow me to introduce the formula that we are going to use to compute WACC, weighted average cost of capital. It is VE, because you also need to know when you are computing WACC, we use, this is the formula, VE, that is value of equity, over value of equity plus value of debt times KE, this is cost of equity, plus value of debt over value of debt plus value of equity. This one is times KD adjusted for tax 1 minus the tax rate. And here we always use the market rate, the market values. Here we always use the market values. That's the formula. So let's go back to what we want to do. I'm going to explain a little bit small as far as IRR is concerned, because we are going to look at it when we go to the investment decision. So when we are doing IRR, we start with the years. We put in a table. We arrange our figures in a table. We start with the years. We put the details. Then we show the cash flows. I'm going to use CF and S to mean cash flows. Then we shall have what we call the discount factor, DCF factor. Then we shall end with the PV, that is present value. So we put it in a table format. But now What you need to know is the fact that we always invest at market price. So in year 0, we always do the investment in year 0. In year 0, we are investing. We are investing at marketing price. So here we are taking the MPS, but it's supposed to be X-int. We invest at market price, and the figure that we are investing, the market value is 95.84. So the discount rate that we are going to use, since we are computing IRR, we can pick any rate. I'm going to use 4%. 4%. So this is going to be 1.00. We are investing, so it's supposed to be in bracket. So this is 95.84. It's a negative because we are investing. In year 1, what are we going to be earning? We are earning what we call interest. This is the cash flow that is going to be coming in the business. We are paying interest, or they are paying us interest. What is the interest? The interest, we computed it. We computed the interest as 5. So the present value at 4% in the first period is 0.962. In the second year, we are also receiving interest. And the same interest is the one that we are receiving, 5. So the discount factor is 0.925. In the third year, they have told us it is redeemable in the third year. In the third year, we are receiving 2 issues. We first receive the interest of 5 with a coupon rate with the discount factor of 0.889 in the third year. But still in the third year, we receive what we call the redemption value. This is the redemption value. And this redemption value are telling us we are redeeming at par, which is 100. It will also have the same, which is 0.889. So you multiply this and then you sum them up. So we multiply these values and then we get the present value. Of course, here we are just starting, but this column you can ignore this column. But I'm only putting it there because we are doing it for the first time. So this first one is going to be 88.9. Then we can multiply these other ones. So we are getting 5 times 0.925. It's giving us 4.63. This is 4.63. And of course, this one is 0.889. And this is giving us 4.4. 4.45. Then this other is 5 times 0.962, which is giving us 4.81. So when you add those, so this is the NPV minus the 95.84. It is giving us 1.073. It is a positive NPV. So we have scenarios. It is always a try and error method. But I don't want to go into deeper into the computations, but we shall maybe look at it when we go to the other side. But the argument that I want you to get is the fact that since we have gotten this as a positive NPV, now we want to look at which rate are we going to use that is going to help us to get a negative NPV, because we need both the positive and then the negative NPV. So it's the one that we are looking at. So we can draw another table. It will have the years. It will have of course, the details. That one I can even skip, but let's put it since it is the first time, details, the cash flows. Then we are also bringing in the DCF. Then finally the present value. So we are also investing in year 0 at the market price, the same value. So here we are picking a rate. Which rate can we pick that is going to help us obtain a lower NPV? In other words, we get a negative NPV. So when you find that you have computed the first NPV and you have gotten a positive NPV, so what do we do to the rate? Because we need to adjust the rate to make sure that we get a lower value. So we are going to increase the rate. If we take, this is a try and error. If you get it wrong, then you keep on trying. So maybe we can take like 10%. This is 1 point. So this is 95.84. It's a negative since we are investing. So in year 1, we are now receiving the interest of 5. Then this is going to be 0.091 because it is 10%. Then in year 2, we are also receiving the same interest of 5, which is 0.826. So in year 3, we are also receiving the same interest of 5, 0.751. Then in the third year, we are redemption of 100, which is the same 0.751. So we multiply the cash flow times, so this one is going to be 75.1. So 5 times 0.71. This is going to give you 3.755, or we can take 6. 5 times 0.826. This is giving you 4.13. So 5 times 0.909. This is giving us 4.56. So we want to make sure that we get 3.76 plus the 75.1. So you can see that this one has given us a negative NPV of 8.31. If we round off, 31. So once you have gotten those two NPVs, one is positive, one is negative. This one has given us a negative at 10%. So we take those rates and we substitute into our formula. So we have a 10% that gave us 8.31, a negative. We also have 4% that gave us 1.0. It gave us 1.073. 1.073. So these are the ones that we are substituting in our formula. We said IRR equal to A plus capital A over capital A minus capital B into B minus A. So we said Capital A, that's our lower rate. Of course, this is 4%. We can just put them in 2 decimals. We say this is 0.04 plus 1.073 over 1.073 minus, this one is already minus 8.31 into 10% minus 4%. Of course, this one you're supposed to maintain. Since we put all of them in decimals, even this one we are supposed to maintain. So this one is going to be 0.1 minus the 0.04. And then you put in the calculator everything and you get the final answer. So this one will turn out to be a positive. This one, it will be a positive times 100. So when I multiply by 100, I'll be getting the percentage as 4.69%. That's roughly 5% if I round off. So you will see that this is our IRR. But now this figure that we've gotten, we've not catered for tax. So we are supposed to get it, to adjust it for tax. So IRR that we've got is 4.69%. So we adjust that for tax. So we are going to get 4.69% into 1 minus the tax rate. The tax rate they are told us it is 50%, which is 0.5. So it is going to be 4.69% times 50%. So you just get the whole of this value and you divide by 2. So it is going to be 2.34%. And that's what we shall use. 4.69. So this is the value that we are going to use as our cost of preference share. So, but there is also a scenario whereby you can first compute the first table and then you get the NPV equaling to 0. We also know that the IRR is that rate that makes the NPV, that equates NPV to 0. So if you compute, and I know it is very rare for you to be able to compute, to pick a rate that is going to help you compute and get the NPV as your first NPV to be 0. Because if you get your first NPV to be 0, then you stop there, you pick that rate to be your IRR. So this is the rate that will make sure that we get NPV equaling to 0. Because we have done something like an extrapolation. We have adjusted within the range. We have used different ranges to actually have that rate that will make the NPV equal to 0. So that's the implication. So you can try out as many numbers as you can, but we are going to look at computation of cost of capital, the overall. Because here we have been computing, we've been computing the specific cost of each item. Since we have done, we want now to look at computation of what we call the WACC, which I gave the formula as the VE over VE plus VD times KE plus VD over VD plus VE times KD adjusted for tax. That's the formula that we are going to go with in the next video. So let me see you in the next video as we are talking about the whole computation of what we call the cost of capital. That is the overall for the organization.